We're having a look at energy and chemical change and specifically focusing on thermodynamics. Now, thermodynamics is the study of energy or heat transfer during chemical reactions. If you have a look at what's happening here at the top, we see a guy that's running and sweating and then he becomes exhausted. Now, we can understand that when we look at this picture, that the energy before, meaning before he actually collapses, is larger than the energy afterwards. After we run, remember, we feel tired, we have released energy. If we look at the picture here at the bottom, where we have the sun and some leaves, life science students, you'll be able to help us on this one. Where we see that sunlight energy is absorbed, we know that the plant's leaves will absorb energy, and therefore the energy before will be smaller than the energy afterwards. I'm going to use these examples in terms of chemical reactions, and let's now say that before the arrow we have our reactants and after the arrow we have our products. So the energy of our reactants, the picture at the top, will be larger than the energy of the products. Then if we look at the picture at the bottom, the energy of our reactants will be smaller than the energy of the products. Now when we discuss this work, we are basically looking at two reactions here. The top one, where energy is released, is called an exothermic reaction. Exothermic reaction meaning that a reaction releases energy or heat, and heat or energy flows from the system to the surroundings. When you run or when you jog, when you exercise, you are releasing heat. You feel your face is full of sweat. You feel warmer. So energy is being released. When we look at the situation here at the bottom, where we have photosynthesis, where energy is absorbed, it is called an endothermic reaction. An endothermic reaction means that energy or heat is going to be absorbed in this reaction. Now, very important here, when we look at this work, there's a new definition, and that definition is the definition for enthalpy. Now, enthalpy is a total amount of chemical potential energy in a chemical system. And we are going to use the letter H, which really stands for heat. So we represent enthalpy with this symbol, and we measure the heat of the reaction by measuring the change in enthalpy. So change in enthalpy is going to be used to measure the heat of the reaction. The formula that we use for the heat of the reaction is change in H equals the energy of our products minus the energy of our reactants. So remember that when we look at enthalpy, enthalpy is the Greek word for heat really. The total amount of chemical potential energy in a chemical system is measured. If we look at our top picture here, if we use our formula change in H equals E of the products minus E or energy of the reactants, we can see that the energy of the product is smaller than the energy of the reactants. And if we go and look at our formula, this is going to give us an answer with a negative value, or we can say that the change in H will be smaller than 0. If we look at our change in H formula for endothermic reactions, change in H equals E products minus E reactants, we know that the energy of the products will be larger than the energy of the reactants, and therefore our change in H will give us a positive value, or change in H is larger than 0. Remember that this is what we use to determine whether a reaction is endo or exothermic, the change in H. But very importantly then, just to summarize, a change in H will be smaller than 0 for an exothermic reaction because energy is being released, and the change in H will be larger than 0 for an endothermic reaction where energy is being absorbed.